I am Fatih. This is the preliminary presentation of the project Pollen Grain Classification for Honey Branding. The objective is to develop computer vision system that, given an image of pollen grain acquired through an optical microscope, will recognize the pollens. The larger aim is honey branding through the pollens in it. This is how the dataset looks like. Every image here represents a different class. First step is to classify given pollen image to one of 30 classes. Second step is detection of multiple pollen instances on an image. And the last step is to keep track of pollens so we can brand honey. Besides certification of honey production, pollen grain recognition is used to establish the location or seasonal time frame for crime scenes, to determine agricultural practices occurring at archaeological sites. Here are some related work about pollen grain recognition. In the first one, they create convolutional neural network with 8 hidden layers, and the accuracy was about 85% on Pollen 23E dataset. In the second one, they used local binary pattern, which is more robust to noise and rotation of pollen images. In this one, they have 389 images with 23 classes. In the third one, deep learning methods applied on Pollen 23E dataset, which consists of 23 types of pollen and 805 images. According to results, combining transfer learning with feature extraction performs better. The next one doesn't classify pollen types, but their development cycles into 5 groups, such as well-developed pollen grain or anomalous pollen grain. But the segmentation process was interesting. They pre-process the image by reducing the background noise, and then transform image to grayscale, apply morphological operators, and then flood fill algorithm to remove connected component smaller than a threshold. And they create a mask by selecting connected components with a size greater than 150 pixels, and they apply dilation to the mask. In the last one, they experimented on 3 types of convolutional neural network training, which are training from scratch, fine-tuning of pre-trained network, and feature extraction. The results show that feature learning produced more accurate results and training from scratch produced inferior results. My dataset contains of 359 images with 30 classes. There are samples with intra-class variance and inter-class similarity as shown in the figures. So how can I achieve the good results with a limited dataset? By data augmentation, like rotating and color shifting. According to related work, transfer learning gives the best results. And pollen grains tend to be clumped to each other, so region-based segmentation might be helpful as well. I'll be using deep learning techniques. In the first step, I'll be working on classification of given scene images, then classification with localization, then object detection of given image with multiple pollens. At last, apply the operation to video streams. I have 3 success criteria. The system will reach at least 80% accuracy in terms of classifying pollen images. Given an image with pollens, bounding boxes should be drawn, outlining the object at least 0.7 mean average precision at 0.5 IOU. Pollen recognition system should be able to run on live video stream at 15 frames per second on NVIDIA RTX 3060. Here are my references. Thank you for listening.